we're going to be talking about almond whole split irrigation strategies. This might be a little late in the game because this is a very early year, but nonetheless, there are still some topics and ideas and processes that we can go through that can hopefully help everybody save a little water, because water is not good this year, as we all know, and it's probably never going to be good with the politics going on out there, and then with obviously the man-made droughts. So this is something that's always going to be on the top of the list. So we're looking to save some water, and there's also some other benefits with irrigation strategies, specifically with almonds. So let me get a little idea about the content of what we'll be talking about today. First thing is going to be almond growth stages. We have to have some sort of high-level understanding of growth stages, because we're going to be applying certain irrigation strategies to different parts of the growth stages with almonds. So we need to kind of have just a brief understanding of that. Then we're going to be talking about regulated deficit irrigation and exactly what is it, and of course the effects of RDI, regulated deficit irrigation, on plant growth and development in general, and then move into the implementation of this process within almonds. After that, we'll move into, what are the benefits? Obviously we're saving water, but there are also some other cool things that you can benefit by proper use of regulated deficit irrigation in almonds. And finally, try to close the loop. How is this plan, and how is regulated deficit irrigation? How does PureSense fit within that within that world? So that's what we'll be talking about today, and I'll be stopping about halfway through for questions if anybody has any. But let's go ahead and jump right into it. So what I have here, as I mentioned earlier, a high-level understanding of the almond growth stages. I purposely omitted January and the last part of the year, and mainly focus on the meat of the growing season, what is actually going on, where most of the irrigated water is being applied. So obviously you have the bloom, and then sometime in March, your rapid vegetative and fruit growth. You're developing canopy, fruiting positions for next year. You're leafing out. A lot of growth is occurring. A lot of fertilizer. Most of your fertilizer being applied during this time. Moving into April and May, you have embryo enlargement, kernel fill. Sometime in June, dry weight accumulation, shell hardening, and then of course whole split. And this is what we'll be focusing on mainly today from an irrigation point of view, and a little bit into harvest, and we'll talk a little bit about post-harvest irrigation and some bud differentiation. So that's a high-level look at the growth stages. Obviously, each one of these can be broken up into many different sub-growth stages, but for the purposes of today, that's not necessarily important. Well, how do you maximize value during whole split? And obviously, deficit irrigation is pretty much the answer. That's where you're going to get your biggest bang for your buck. There's a lot of positives, of which I will be getting into, but that's where the value is. It's the irrigation at that time of the year. So regulated deficit irrigation, what exactly is it? And a lot of you guys may be familiar with it, so if I'm going over something you already know, please bear with me. But RDI is actually the process at which a reduction in applied water, so you're reducing what you're giving to the plant, and the intention is to induce plant stress. And you have to induce this stress at tolerant periods of the growth cycle. So again, you have to understand the growth cycle, then you have to understand the sensitivity to irrigation of all these growth cycles and apply that stress for a positive outcome. And proper use of regulated deficit irrigation, again, will reduce applied water and have an insignificant effect on production. Yes, production will be slightly off, but it's an insignificant amount. And it's on the other side of the scale, there's actually a positive effect, or can be a positive effect, on fruit quality and, of course, harvest efficiencies. And understanding these interrelations, the effects of plant growth and development in relation to the growth cycle is the key. So that's regulated deficit irrigation. And moving into a little more in general, kind of like an overview, when you reduce water to a plant, what exactly is happening? How is RDI on plant growth and development? How does it affect what's actually going on? Well, what I have here, if you can see my pointer, this is an electron microscope slide of the underside of a leaf. And this is the area where all the gas exchange occurs. And it occurs through structures called stomata. And stomata are little small openings to the atmosphere on the underside of the leaves, again, where gas exchange occurs. They are regulated by guard cells, which are these structures right here, which can open and then close this aperture based on certain environmental conditions outside and within the soil profile. In this case, these stomata are completely open. On the right side, they are completely closed. How it's regulated is basically having the understanding of soil moisture, and if the soil moisture is very close to field capacity, it's very easy for a water molecule to move into a root, move up the vascular tissue, the xylem of the plant, and out through the underside of the leaves. And in that case, when there's a lot of soil moisture, you have a lot of gas exchange. These are completely open on all the stomates are open, and you're getting 100% gas exchange, carbon dioxide, oxygen, and water. And that's the movement of carbon dioxide into the stomate and into the plant for carbon assimilation that's where it is used obviously for making pretty much everything, stems, fruit, leaves, floral structures, everything is dependent on carbon assimilation. So the idea is if you have proper soil moisture, then what will happen is these will be completely open and you will have 100% the highest amount of gas exchange that you can have, and you'll be building a plant. The understanding that water column within the xylem, there's no cavitation. All the water molecules are connected. So as a water molecule leaves this stomate, another one will enter from the root. It's like a one-to-one in and one out. Let's just say, for instance, your movement into a high soil moisture depletion. You're starting to dry out. So what's happening is it's harder for the plant to actually move water into the roots. So as a defense mechanism, the guard shells will shut down and close the aperture right here. And what that does, it increases the tension within the water column and allows it to pull water into the root. As a negative, you have less gas exchange. So if these things close by 50%, then you're getting 50% less carbon dioxide in your plant, and what you're going to see is that's where you see your stunted growth. Leaves begin to wilt, internode length is shortening up, and the plant is simply not operating at full potential because of the low soil moisture. If your intention is to shut the plant down, then that's what you want to do. You want to lower your gas exchange and limit the growth, and that's basically what we're doing here in the almonds. We want to induce this stress. We want to close these stomates at a certain time of the year. Okay, moving on. Now, understanding this, so that's what we're trying to do. We're trying to limit gas exchange, slow the plant down. So how does RDI how do you implement this in almonds? And what I have here is the same growth stages that I showed earlier. And what I'm going to do is I'm going to present different times of the year where you would want to have high gas exchange and high transpiration, and times of the year which would be tolerant. So what we have here is, and again, just for clarity here, this is for the nonpareil variety. Obviously, there's many, your pollinators, your hard shells are going to come off at all different times. So these can be shifted one way or the other depending on variety. And there's a ton of varieties out there, but nonetheless, the main one would be nonpareil. So this is how I see it. Obviously, I put it into sensitive, moderately sensitive, tolerant, highly sensitive. This time of the year, starting at the left side over here, I would consider that sensitive. You're trying to get the canopy, a lot of fertilizers going in the ground, a lot of metabolic activity is occurring. You simply do not want to limit gas exchange, and you do not want to deficit irrigate during this time of the year. As you move over into May and the first part of June, or most of June, it's moderately sensitive. You can induce some stress during this if you're really in a bad situation with water. Then you can deficit irrigate here. However, you will most definitely have smaller kernels. Your weight's going to be less, and that's might be a trade-off if you're not good on the water. However, as you move into July and August, highly tolerant. The nut is made. You don't necessarily, if you cut back on your water this time of the year, You're not going to have a big effect on this year's crop, obviously, which is already made, and next year's crop. As you move over to the right, I call this area highly sensitive. Both the front end and the back end of the season, they're both kind of highly sensitive, but I've made this a little more important here. This is when bud differentiation is occurring. This is post-harvest, so you're looking at late August, first couple weeks in September. This is when you're setting your crop for next year. And there's been a lot of studies that have indicated that shorting water on this time of the year is going to hurt you a lot in the long run. So for those of you really short on water, this is a time of the year where you just simply, this is where you would put your irrigation if you're short. Now next I'm going to go ahead and layer a plan and compare a fully irrigated tree versus an RDI treatment. If you look up here on the right, this is ETC, which is the amount of water the crop is going to use. I have it in percentages, as you notice, 100% across the whole year. This is stomates open all the time. Allow the tree to transpire at whatever rate it wants to, depending on the temperature and the environmental conditions. This is the crop curve. And then below that, I translated that into inches of applied water. You've noticed I get to my number 42.8 inches. I know that's not the magic number 48 that at least I'm familiar with. Keep in mind, I don't have any pre-irrigation in on this, and I don't have any a lot of the post-harvest irrigation, which would get you to the 48 inches. There has been some studies that indicate that it might be high as 54 inches. I remember back in the 90s, the amount of water that was described by the university was somewhere in the 43 to 44 inches. Of course, back then they weren't getting 3,000 pounds. Anyway, so now the RDI. This is a plan where you want to induce stress during this tolerant period. If you notice the first part of the year, no change, 100%. We don't want to slow the plant down. Even if it were tolerant this time of year, and let's just say that you could deficit irrigate, you're not going to get much bang for your buck because that time of the year evapotranspiration is really low, and you're not going to really save much water here. It's only 1 inch in February, almost 3 inches in March. It's not the big numbers like you see over here. As you move more to the right, again, I have it 100% ET into the latter part of June. At that point, especially like this year, when the crop has moved up, you can, the last week in June, or in some other years, maybe in July, as you're approaching hull split, move your applied water to 75% ET for the last week. You're going to get a little bit of a water savings here. And what you're doing is you're trying to condition the crop for hull split. As you move into July, a lot of the research, specifically by Dr. Goldhammer at Kearney Ag Center, has done a lot of work looking at how much can you reduce it without having an effect, and 50% seems to be the number. Blake Sandin, farm advisor out at Kern County, is actually beginning on a study, a 4-year study, large-scale, in-depth study on verifying that some of the work that Dr. Goldhammer has done, and looking at whether or not 50% is the magic number. But as we stand today, you can knock it back by 50%. You can save almost 4 inches from a fully irrigated tree during July. As we move into August, and again, this is, that's week 1, week 2, week 3, week 4. I'm just saying you're harvesting somewhere in the 3rd week of August. This is just an example. Keep in mind, you don't necessarily, once hull split is pretty much complete, and now you're looking at drying the nuts, the abscission layer on the nut is already starting to form, so the nut is disconnecting, physiologically disconnecting from the tree. So there's no sense to maintain a 50% reduction in water at this point, because now you're actually hurting the tree. The nut's made, and it's going to harvest. So my recommendation would be to increase the water up pre-harvest. I got it at 75%. This comes a tricky time of the year. If I've done it to where I've gone 50% all the way through and then shut off for 12 days, and the trees look like garbage. But we didn't defoliate them, and we were kind of walking the line there. I've also had situations where I've gone back up to 100% ET, and then you end up barking the trees. So that's going to be a judgment call for you guys. You know your trees. You know what they can stand. You don't want to put too much water on, obviously for ground prep and getting ruts in the field and whatnot. You also don't want stick tights if you go on the low end. So this is kind of a judgment call area, and this is just recommendations, but you're still going to get some sort of water savings during this time. And then moving on into the highly sensitive, bang the water away, 100%. My experience is that, like with the nonpareils, the second that those nuts are windrowed, I'm coming back with the water. I've actually even talked to some guys who actually turn the water on even before they're windrowed, because it's that important for the next year to get that water back on and get that profile full, and don't lessen gas exchange during this time of the year. So anyways, 8.7 inches, that's just a high-end number. Everybody's going to vary. And at this point, I think I'd like to stop if there's any questions.
So I'll go ahead and I'll open up all the mics. Like I mentioned earlier, the feedback may get in the way, so we'll turn off the mics as David answers any questions. So the mics are now on. I see some people turn their own mics off, but if you'd like to ask any questions, then you can turn your own mic on and then go ahead. I'd like to make sure I give enough time just in case anyone has a question. Otherwise, then we ask David to continue.
Move forward.
Yeah. Give me 1 minute to turn all the mics on or turn off, and then turn yours back on again. As I mentioned earlier, if you got any other questions, please go ahead and feel free to type them in the chat window, and then I'll interrupt and then ask the question. Okay, David, you're back live again.
All right, thanks, Andy. Okay, moving on. Benefits using RDI and almonds. Obviously, it's implied that you're going to get up to 8 inches of water savings without affecting production. And as I said, that's kind of on the high end. That's almost an acre foot. If you do some sort of RDI, it's going to be a number between 0 and 8, and that's, again, 8's on the high end. Just put it up there to show how much you might possibly save in water. Also, in the ability to move up whole spit a few days. This year, not necessarily that big of a deal. We had a pretty warm, dry spring. A lot of heat units, of course, moving into this year. We're ahead of the game, so there's no real benefit in trying to move it up. But I do remember I think it was 2009 or 2010, we had a really cool, wet spring. We didn't develop too many heat units. We were behind by 12 to 14 days, somewhere in that range. And also that same year, we had some early range coming in the fall. A lot of guys got caught, including myself, with a lot of nuts on the ground. Even some that were windrowed when it rained a lot, and we lost a lot of. We looked pretty stupid actually, but we lost a lot of nuts to the rain that year. So in years like that, if you know that that's going to happen, try it. You could probably start a little bit earlier, and you could push whole split up by 3 or 4 days, maybe even more, depending on your soil type. And that's always a positive thing, because on years like that, the harvest tends to condense. In other words, the time between your nonpareil and your pollinators is squished together, and then you get in a situation where you only have so much equipment, and everything's kind of jumping on top of each other. So if you can move it in a little bit earlier and get that equipment in the field, and then affect the back end and get the nuts off the darn ground before hopefully it doesn't rain, that's always a positive. Also, using RDI, the accelerated whole splits allows for more in-tree drying on the tree. Obviously, you want to limit the amount of time that these nuts are on the ground. Nothing really good happens when nuts are on the ground. There you can get ant damage, soil-borne bacteria such as salmonella, not necessarily what we want. So the more in-tree drying we can have, obviously we know we have to put them on the ground, but not for a long period of time. So it aids in that. Another thing that RDI would do, it condenses your nut maturity within a tree. Let's just say you have, say, 7,000 nuts on the tree, and we all know that all 7,000 aren't going to pop or split the same day. There's going to be a lag time. It could be 12, 14 plus days between the time your first nut splits open and the time your last nut splits open. And that's going to, of course, translate to when you shake. You don't really want to shake a tree when on the one end of the scale you have hull moisture, say, plus 30%, and then on the other end of the scale it's down at 12%. Same goes with the meat moistures. You know, what it might be as high as 15, 16% when you're shaking, and as low as on the same tree you could have a nut that could be at, you know, 5%. And by the time you harvest, that nut that's at 5 or 6 might be at 3%. So the idea is that you want to decrease that time between the first nut splitting and the last nut splitting, and using RDI is gonna condense that. And obviously, when you go to shake, more of the nuts will come off in the tree, and you get more into the to the huller. Another positive is the ability to control hull rot on fields that are prone to this disease. And this hull rot is in some areas can be a problem, in some areas it can't. It's kind of like a good farmer's disease. You got too healthy of a tree, too much irrigation, too much fertilizer, really dense canopy, a lot of high humidity. Utilizing an RDI regime will suppress this disease. And again, that's if you do have it. Okay, now that's kind of like the plan, but I haven't really mentioned anything about PureSense yet. So a few things you have to understand is before attempting to implement your RDA plan, you have to understand what is water for fully irrigated trees. You have to know that 100%, as I showed earlier, you know, the one where I had 8.3 inches in July. We need to know where that line is. And in the software, there's areas, and I'll get into that. Then we need to know what we did. There's a couple ways to get the actual applied water. You can read your meters. We do have a flow meter monitoring product that's pretty new, where you can attach a meter to your field and get exact applied water per irrigation event, or you can calculate the applied water using your pressure switches, which I think is an incredibly valuable tool that is probably underused for some growers utilizing PureSense. And then, of course, you compare the two together and figure out where you are against ET and figure out what you did. Did you do the 50%? Did you, maybe it was 75 and things like that. So you have to know those two things, and PureSense can help you along the way with quantifying those two numbers. And also, you have to understand the related graphical results. The graphs have to validate what you're doing in the field. Say, for instance, you are trying to go 50% ET during this whole split time. So when you're looking at your graphs, you need to see some sort of reaction that indicates that's what you're doing. If you don't, then you need to go to your SMP site and look, and maybe there's a leak right there, or maybe you have cracking ground. You do not want these graphs to mislead you. So with a little more knowledge on what you're trying to predict what's going to happen, you should get the same. You should get those results. And I have an example of a graph later on that I'll show you. Then you have to create an RDI plan using the Irrigation Planner tool. We do have a tool within the software that allows you to put in the numbers that you want. Say you're on fan jets and you can't shut one variety off and irrigate the other variety, or maybe you're on a sprinkler that you don't think 50% is going to work for you, so you can go in 75 or even whatever number you want. So that's the Irrigation Manager tool. I'll show you a little bit later. And then once all that's in place, now you can produce reports. I'll show you an applied water chart, which compares the amount of water you put on versus what you wanted to put on. Obviously, the soil moisture trend chart, that's the one we're all familiar with the lines that go up and down. Don't need to explain that too much. And then the irrigators report. This is one that I particularly like, because I like to look at applied water as a volume. A lot of growers I talk with, we use the term hours a lot. I did 24 hours, I did 48, or whatever the number is. In reality, what we're really looking at is volume of water. We're looking at, I put on 1 inch. It could take you 30 hours to do 1 inch. In some cases, it could take you 12. So the irrigators report, the unit of measure is inches, and that's important to me. So we'll look at one of those reports a little bit later. And with all that, you can track your performance against your plan using these planner reports. This is, in order for anything that I said earlier to occur, this has to happen. You have to build out your irrigation sets. And if you guys have already done this, then please bear with me on this one. But the the software needs to know what your capacities of your irrigation systems is in order to make these assumptions, well, not really assumptions, make these calculations using your pressure switch data. If your pressure switch is on for 10 hours, well, then we need to know what your hourly application rate is. This is very easy to do. If you haven't already done it, you can contact your support manager if you're unfamiliar with it, or there's really good videos on the web that shows you how to build your irrigation sets. And this isn't just necessarily for RDI. This is all time. For all irrigation events, looking at your applied water from a volume basis, you have to have this done. And it's easy. You put in your emitter flow rate. You have your spacing over here, and then it's calculated your application rate. In this case, it's 0.056. And also there's system uniformity. In this situation, the grower did actually do an official distribution uniformity test, and they got 88% uniformity, which I consider very good. If you were on one of my previous webinars, we do have a service called, we're doing the DU testing as a service. This is where we use the method from Cal Poly ITRC, and we kind of bend it a little bit with some agronomic angles to it. We go out, we do catch cans, we do flow rates, it's repeatable, it quantifies, it's a snapshot in time, and you can get a really good number to put in here. And we've probably done well over 100 of these, and I've seen some fields, the highest I think I got was a 92%, and we've seen some in the 50%. So didn't want to really go off on a tangent right there, but again, that's distribution uniformity, and this is building out your sets. Right here is a reference ET system. This tells you what a fully irrigated tree is going to use based on wherever you're at in the valley. This data is from CIMIS. It gives standard ETO for all the times of the year. That's the reference crop and grass for whatever it is. In this case, I've got the northern and southern San Joaquin valleys highlighted. This is your ETO in inches. This right here, we have many different crops that you can choose from. Pretty much most all crops grown in California, but here I have selected almonds, and this is the associated crop curve. My mouse is messing up. Okay, this is the associated crop curve for almonds, so this number times this number gives you this number. This is your 100% right here. So if you follow along this line, you're going to be transpiring at a full rate throughout the year, and in some crops this is what you want to do. In other crops like almonds, you certainly don't want to put the 8 inches on in July. You have to reduce that. But this is just for fully irrigated trees, and this gives you your baseline. And of course, this is an irrigation manager. One more thing I'd like to point out is before I move to the next slide, is we are moving into a different software platform. We're going to make this screen a little more robust. We're going to allow the grower to not only pick your zone, and we're going to allow you to manipulate your KC values. Studies are always coming out when there's changes. You may have regional differences. You may say, I don't like it at 0.95%. This time of the year, I'm going to go ahead and go at 1.1. If you're inclined to mess with these numbers, right now this is static, but it does allow you to give you a baseline to compare against. But in the future, we'll allow you to play with it. Then you got to build your plan in the planner. What this does is it allows you to customize certain times of the year. In this case, I'm doing it by growth stage. You can have as many stages as you want here. You can do it by week, by month. It doesn't necessarily matter. I have it by growth stages. And what this is doing is taking that time of year and taking that reference ET data that I showed you in the other page and putting it into this column right here. So this is fully irrigated based off whatever reference ET you pick and whatever time of the year. Over here to the right is how you manipulate what you want to do against this. So this would be, in bloom, I'm going up. I want to go 15% of whatever whatever ETC is. I have 30% decrease here. I probably should have knocked that down to, 50%, but this is didn't have time to move the slide over. But nonetheless, you'd have a deficit irrigation here. We're having some refill here. Dormancy, I've got that at 75% of whatever ETC is because I'm including some pre-irrigation. You get to your 42 inches. Again, that's probably a little bit on the low end, but nonetheless, this is completely customizable, and you can use this in some of the reporting to compare against what you did. Now the graphs, we're all familiar with these. This right here is showing kind of like a classical whole split strategy. As you notice, this, okay, first off, it goes from June through October there. Uh, good water balance here. Good soil moisture all the way down to the bottom. Uh, these guys played it just right. This is out at CIT at Fresno State. They played it just right throughout the year. Again, the times of the year you don't want to stress, they weren't stressing. That's desirable. Whole split was around the 10th, and then they went down to a 50 to 75% ET. And as you can see, you're starting to use water towards the bottom. This is kind of what you want to do. We're starting to induce stress here. Even at the onset of harvest, they still had some water on the bottom. And of course, that goes bye-bye by the end of harvest. But nonetheless, this graph validated whatever the plan was. If this graph didn't look like this, then you need to go out to your site and either make sure that that's what you're seeing. You could have a poor DU in the field and may not realize that area of the field is receiving more water than the rest, but nonetheless, this should match what you're trying to do. They came in to harvest it again here. A little bit of bump right here on the second foot, nothing really happened on the bottom. And of course, you got your refill towards the end. By the end of September, early October, they got water down to the bottom foot. The only critique I might have is I would like to have seen this refill occur a little bit earlier, and I know sometimes it's hard with the ground seals up and towards the end of the year, but nonetheless, in a perfect world, I'd like to see this move back a little bit because bud differentiation is occurring during this period. But nonetheless, good job on this graph, and we'll just go ahead and move on. A lot of you are already familiar with these graphs. One of the charts you can do, and this isn't actually from the field we're doing, but if you have your sets built out, if you have a plan, then it allows you to make a simple line graph showing where ETO is, where ETC is, and where you are. And this, again, is if you have to have the sets built out. And pretty good information here. They're right in between. They're a little bit more of what they wanted to use. Again, this isn't from the almonds. This is another crop. But yours should be down below ETC during this period right here, because that's where whole split is occurring. And this is the irrigation report table. Again, this is the one that I like because it translates everything. It translates things that make sense to me, which is volume of water, not hours. This number doesn't kind of means something to total irrigation hours, but this is the number I'm really looking at. That's 7.74 inches. You can do it for whatever time period you want. In this case, I picked the month of July in 2012. If you're, for instance, looking to generally in July, I said it's 8 inches fully irrigated, so that would be, of course, 2 inches a week. If you're doing 50% ET, that's 1 inch. You can set this range from 7.1 to 7.8, and in a perfect world, this would say 1 inch or maybe 1.1 inches. If it says anything different, then you need to dig in a little deeper. So this is my reality check because this is again the volume of water, and of course you got seasonal or year-to-date information to the right too. If I did this for the whole year, then you would see what you did for the year. Then did you hit that magic 48 inches for almonds, or were you below or above? And lastly, another report that you can do, again, if you have your plan set up and you have your sets built out, this is just a bar graph comparing what you did versus what you wanted to do. In this case, they're 3.7 inches above what they wanted to do. Has been hotter. ET is a little bit higher this year, ETO. So you don't have that information when you're making the plan. So they do vary by year. I've seen some years where it's 10+% above or below whatever the normal is as far as crop water use in the season. So keep that in mind when you're looking at some of these graphs compared to a plan that was made a while back. They did a little bit more here, not much in bloom, and of course, whole split this is for this year. Still going on. Eventually, they should make it up somewhere in this range by the end of this period. And of course, there's your rest of the year, which hasn't occurred yet. And with that said, I'd like to open it up for questions if there are any.
The mics are now open now, so if you'd like to ask any questions, you can go ahead. Then I'd ask if it's okay. We'd love to get your feedback, say in any email form, as I work with David and he does these presentations. It's always hard because if you don't hear people's voices, you don't know necessarily what they're reacting to or what they're finding interesting or what they'd like more information about. So we'd appreciate if you take a little bit of time just to write that email for David to reflect on how we might improve these, either technically or in the content of the presentation. Is there anything else you have from your side, David?
No, again, it's thanks guys for taking time out, and wish everybody luck on the upcoming harvest. Hopefully they don't get nailed by rains or anything. Hopefully everything comes off really good and easy. Got high turnouts, and best of luck to everybody. Again, thanks for showing up.
Yeah, I see that there was one question that came in from Bruce asking if the presentation would be available, and I'm sure, David, that there wouldn't be any issue with just making it available, but I'll also create this as a YouTube video, so you can always watch back.
It's going to go on the website, and you know, I'll probably make follow-up calls with everybody and see if there's any questions, you know, specifically with their situation, and so you might be hearing from me within the next week or so. And at that point, you can ask for slides.
Great. So thank you all for attending, and yes.